Hello, hello, hello everybody, and welcome back. Root Beer here as always, and in this video we're going to take a look at the 2016 Grade 8 Gauss paper. We're up to question number 24. So let's have a look-see, shall we? Alright, question 24, nice, plain, and simple. What is the tens digit of 3 to the power of 2016? Now, there's nothing particularly special about 2016, it's just the year. So they're just trying to pick a really big number, so we can't just grab our calculator and work this out. Okay? So, well, what are we to do? We're going to end up looking for a pattern. What we want is the tens digit. And so we're going to just compute a few, hopefully a few powers of 3, and see what we can see if we notice anything. Okay? Having seen a number of questions like this over the years, I know that there will be sort of a cycle and this will eventually repeat. And this all comes down to a sort of a broader topic of study that you may or may not be interested in looking into, called modular arithmetic. And so if you like questions like this, or if you find you're really bad at a question like this, looking into modular arithmetic might be something you should do. You know, if you like it, if you like these sorts of questions, you can learn more about this field of study. If you don't like these sorts of questions, learning the theory that comes with understanding modular arithmetic might make these easier. Exposing yourself to things that are difficult makes them less scary. But we're looking for the tens digit. We have our 5 options, but let's dive in and see what patterns we can see. So I'll start with a few and see if we can notice anything. So the first few. So 3 to the 0, I have it included here. Now, 3 to the 0 is 1, but since we're interested in the tens digit, I'm going to write 0, 1. I'm just going to keep the last 2 digits. If you do know modular arithmetic, I'm working mod 100 to get just the last 2 digits. 3 to the 1 would be 3, but I'll write 0, 3. Same with 0, 9 for 3 squared. 3 to the 3, 27. So now our tens digit is 2. And then we go to 81. Now, 3 to the 5 is 243. You can grab your calculator and work that out, or multiply 81 by 3. But what I want to show you is that we don't actually care about the 2. I'm keeping track of the last 2 digits. So it's 43 as far as I care. Now 3 to the 6 is 729, but we don't want to keep reaching for our calculator and working out these big powers of 3. Besides, we don't actually care about most of the digits. Oops. We don't care about the 7, we're just interested in the 29. Now the interesting thing is this. If I just take 43, not 243, and multiply it by 3, I'll get 3 times 3 is 9, and then 3 times 4 is 12. The last 2 digits are the same. And this isn't a coincidence. If we just care about the last 2 digits, having the 2 here for 243, the 3 and the 2 don't really interact until you're already computing the hundreds digits. So the nice thing here is, to continue filling out this list, I don't need to continue making powers of 3, which would be a very bad idea, because eventually my calculator will stop displaying them. Okay? That's part of what makes this question so difficult in the first place. If my calculator would display all the digits of 3 to the 2016, I wouldn't have a problem. I'd just press a few buttons, maybe have to scroll a little bit or something, but I'd just read off the tens digit. Okay? So now to get 3 to the 7, I can just take the 29 and multiply it by 3. Okay? So 29, multiply it by 3, and it'll end with 87. You can either work that out on your calculator. This is small. 3 to the 7, I know, is 2,187. I actually haven't had my calculator on me for the whole question. But we are quickly approaching my limit of powers of 3 that I know. I know 3 to the 8 is 6,561. So this is 61, but we can just double check. 87 times 3, you get 1, you carry the 2. It should be 26, but we just care about the last 2, 61. I don't, off the top of my head, know 3 to the 9. Okay, I'm fully willing to admit that. But this should be 183, just mentally multiplying 61 by 3. We don't care about the 1. It's 83. The last 2 digits are 8 and 3. 3 to the 10. Now, I'll do 3 to the 10. So 83 times 3. What are the last 2 digits of 3 to the 10? 9 and 24, so 49 here. Okay. So there we go. I don't want to erase that. I think we'll probably just need another page. But let's stop for a moment and consider what patterns we've got. And at this stage, there's not really a pattern in terms of the tens digits that we can see. 0, 0, 0, 2, 8, 4, 2, 8, 6, 8, 4. I'm not entirely sure. But if we did look at the units digit, a pattern has emerged. And eventually a pattern will emerge for the tens digits as well, or the last two digits. But for the units digit, it goes 1, 3, 9, 7, 1, 3, 9, 7, 1, 3, 9. The next one will be 7. The nice thing about this is once you hit 7 and multiply it by 3, you'll end with a 1. And that starts everything in motion again. The 1 goes to the 3, to the 9, to the 7, back to the 1. Okay? And eventually, we're going to get the same two last digits. And how do I know this will eventually happen? Well, think about what possible last two digits 3 to the something can have. There's not an infinite number of them. There's only, at most, 100 of them. And in fact, 50 of them, because you'll never get an even last two digits. But there's only 50 of them. You're going to eventually run out and repeat. And because, as I've already noted, the last two digits, you just need to multiply them by 3, and that helps you determine the next last two digits. As soon as we repeat, as soon as we're back to 0, 1, or 29, or 81 or something, it'll just keep going from there. Okay? All I need to do is sort of find the place where it cycles. It hasn't done this in the first 3 to the 10, but hopefully we're getting close. Hopefully this doesn't take too long. At worst, it should take 3 to the 50, but we don't want to be spending that much time on a question, and if we can't find it after a little while, we're probably going to say, well, let's just move on to 25. Maybe I can do 25 in the time that's left for this paper. We don't want to run out of time. Okay, so 49 times 3 will be 147. Well, we just care about the 47 there. 3 to the 12, it'll be a 1, carry a 2, 3 times 2, so it should be 41. Okay. Yeah, it'll be 141. Yeah, that makes sense. 3 to the 13, multiply by 3, you'll get 123, so just the 23. Multiply that by 3, you'll get 69. Multiply by 3 again. You will get, should be a 7, carry a 2, 3 times 6. So it should be 207, so it should be 07. Well, we're back to a 0. That's kind of interesting. Multiply that by 3, and you'll get 21. Multiply that by 3, and you'll get 63. So we're making progress. I don't know how many more I'm actually going to need. Actually, it could be 318 for all I know. Multiply by 3, so 3 times 3 is 9. Nothing to carry. 3 times 6 is 18. We just care about the 8 part of that. Multiply by 3 again. So it'll end in a 7. 3 times 9 is 7. Carry a 2. 3 times 8 is 24. Plus 2 is 6. 26. But 6, 7. I think this should be it, because 67 times 3 is 201, but we just care about the 01 part. And now we're back to the start, and so multiply that by 3 again, you get the 03, and then you get the 09. You can see we're back to the beginning. So what have we learned? Well, the pattern repeats every 20. So without having to actually work it out, I know 3 to the 27, or 47, or 67, or 87, or 107 ends in 87. 3 to the 28 ends in 61. Okay, that's what we've sort of learned here. So this we repeat every 20. So how does that help us? Now that I know the pattern, what can I do? Well, 3 to the 2016 is going to be the same. It's going to have the same last two digits. Now again, we just care about the tens digit, but we're working with last two digits for now. But it's going to have the same last two digits as 3 to the r, where 2016 has a remainder of r when we divide by 20. And 2016 is really nice to work with. It's going to have a remainder of 16 when you divide by 20, because 20 times 100 is 2,000. And then you got your 16 left over. And because of all the work we did, I know that 316 ends in, what was it? 21. And so the tens digit will be a 2. The ones digit will be a 1. They didn't ask for that. So that should be B, because I think they went up in order 0, 1, 2, 3, or 0, 2, 4, 6, 8. Yeah, absolutely. So there we go. We've got our answer of B, and we can move along to our very last question. That'll be question number 25. I'll see you for that next time. Take care.